When installing electrical nonmetallic tubing, often referred to as ENT, through metal studs, the use of bushings is indeed required. This requirement stems from the need to protect the ENT from potential damage. Metal studs typically have punched openings or edges that can be sharp or abrasive. Without proper protection, these sharp edges can rub against the ENT, potentially causing damage to the tubing itself. Damaged ENT can compromise the integrity of the electrical wiring contained within, leading to a variety of electrical hazards. These hazards could include short circuits, ground faults, and even electrical fires. Bushings are designed to provide a smooth, protective barrier between the ENT and the metal stud. They are typically made of plastic or other non-conductive materials and are designed to fit snugly into the opening in the metal stud. This creates a rounded, non-abrasive surface that the ENT can pass through without being damaged. There are different types of bushings available, so it is important to select the appropriate type for the size of ENT being used and the size of the opening in the metal stud. Some bushings are designed to be snap-fit into place, while others may require adhesive or other means of attachment. It is also important to ensure that the bushing is properly installed. This means that it should be securely fastened to the metal stud and that there are no gaps or sharp edges exposed. Failure to properly install the bushing can negate its protective effect and still leave the ENT vulnerable to damage. The National Electrical Code, or NEC, provides specific guidelines for the installation of ENT and other types of electrical wiring. These guidelines are designed to ensure the safety and reliability of electrical systems. It is important to consult the NEC and any other applicable local codes to ensure that the installation is in compliance with all requirements. The NEC addresses the protection of conductors for abrasion in several sections. While a specific section may not explicitly mandate bushings for ENT through metal studs in every circumstance, the general principles of protecting wiring from damage necessitate their use. For instance, NEC Section 300.4 addresses protection against physical damage. This section emphasizes the need to protect wiring from punctures, abrasions, and other forms of physical damage during and after installation. When ENT passes through metal studs, the edges of the stud openings can pose a significant risk of abrasion, thus necessitating the use of bushings or other approved methods to mitigate this risk. Furthermore, NEC Section 358.30 specifically addresses securing and supporting ENT. While this section primarily focuses on the methods of fastening and supporting ENT, it indirectly reinforces the need for bushings by emphasizing the overall integrity and protection of the raceway system. Properly installed bushings contribute to the secure and supported installation of ENT by preventing damage at penetration points. In addition to the NEC, local electrical codes and regulations may also have specific requirements for the installation of ENT. These local codes may be more stringent than the NEC in some cases, so it is important to be aware of and comply with all applicable requirements. When selecting bushings for ENT installations, it is important to consider several factors. Firstly, the size of the ENT must be matched to the appropriate bushing size. Bushings are typically available in various sizes to accommodate different diameters of ENT. Using an undersized bushing can restrict the passage of the ENT, while an oversized bushing may not provide adequate protection. Secondly, the material of the bushing should be compatible with the ENT and the surrounding environment. Bushings are commonly made of plastic, nylon, or other non-metallic materials. The selected material should be resistant to corrosion, temperature extremes, and other environmental factors that may be present. Thirdly, the design of the bushing should be appropriate for the specific application. Some bushings are designed for use in dry locations, while others are suitable for wet or damp locations. Some bushings also have features such as locking mechanisms or strain relief to provide additional security and protection. The installation of bushings is a relatively simple process, but it is important to follow the manufacturer's instructions and best practices. Firstly, ensure that the power is turned off to the circuit before beginning any electrical work. This is a critical safety precaution to prevent electrical shock. Secondly, clean the edges of the opening in the metal stud to remove any burrs or sharp edges. This will help to ensure a smooth surface for the bushing to seat against. Thirdly, insert the bushing into the opening in the metal stud. Some bushings may snap into place, while others may require adhesive or other means of attachment. Fourthly, carefully feed the ENT through the bushing. Avoid pulling or straining the ENT, as this could damage the tubing or dislodge the bushing. Fifthly, inspect the installation to ensure that the bushing is securely fastened and that there are no gaps or sharp edges exposed. This final inspection is important to verify that the bushing is providing adequate protection to the ENT. In addition to bushings, there are other methods that can be used to protect ENT from damage when passing through metal studs. One alternative is to use conduit fittings, such as connectors or couplings, to provide a smooth, protected transition. These fittings are typically made of metal or plastic and are designed to be securely fastened to the ENT and the metal stud. Another alternative is to use grommets or edge protectors. These devices are typically made of rubber or plastic and are designed to fit over the edges of the opening in the metal stud, providing a cushioned barrier between the ENT and the metal. The choice of which method to use will depend on the specific application and the requirements of the applicable codes and regulations. It is important to carefully consider all options and select the method that provides the best protection for the ENT and the overall safety of the electrical system. In summary, bushings are a required component when running ENT through metal studs. They provide essential protection against abrasion and potential damage to the tubing, ensuring the safety and reliability of the electrical wiring contained within. Proper selection, installation, and adherence to the NEC and local codes are crucial for a safe and compliant electrical installation. Failure to use bushings or other approved methods to protect ENT can result in electrical hazards and code violations. Therefore, it is always best to err on the side of caution and ensure that all necessary precautions are taken to protect the ENT from damage. When working with electrical systems, safety should always be the top priority. Always follow all applicable codes and regulations, and never hesitate to consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Remember to always de-energize circuits before working on them, use appropriate personal protective equipment, and double-check your work to ensure that it is safe and compliant. By following these guidelines, you can help to ensure that your electrical installations are safe, reliable, and in compliance with all applicable requirements. Consider this example. If you are running a 1/2 inch ENT through a metal stud, you would need a bushing specifically designed for 1/2 inch ENT. The bushing should fit snugly into the opening of the metal stud and provide a smooth, rounded surface for the ENT to pass through. If the opening in the metal stud is larger than the bushing, you may need to use a reducing washer or other adapter to ensure a secure fit. Another important consideration is the type of metal stud being used. Some metal studs are made of thin gauge steel, while others are made of heavier gauge steel. The thickness of the metal studs can affect the amount of abrasion that the ENT is exposed to. If you are using thin gauge metal studs, it may be necessary to use a more robust bushing or other protective measure to prevent damage to the ENT. In addition to protecting the ENT from abrasion, bushings can also help to prevent the spread of fire. Some bushings are made of fire-resistant materials that can help to contain a fire within the electrical system. These types of bushings are often required in commercial and industrial applications where fire safety is a major concern. When installing ENT in fire-rated walls or ceilings, it is important to use fire-rated bushings and other fire-stopping materials to maintain the integrity of the fire barrier. Fire-rated bushings are designed to expand and seal the opening in the wall or ceiling in the event of a fire, preventing the spread of flames and smoke. The NEC provides specific requirements for the installation of ENT in fire-rated assemblies. These requirements are designed to ensure that the electrical system does not compromise the fire resistance of the building. It is important to consult the NEC and any other applicable building codes to ensure that the installation is in compliance with all requirements. In addition to the NEC, there are also other standards and guidelines that may be relevant to the installation of ENT. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for ENT and other electrical products. These standards provide guidance on the design, testing, and performance of electrical equipment. It is important to be familiar with these standards and to use products that meet or exceed the applicable requirements. Another important consideration when installing ENT is the grounding of the electrical system. The NEC requires that all metal parts of an electrical system be properly grounded to prevent electrical shock. This includes metal studs, conduit, and other metal enclosures. When ENT is used in conjunction with metal studs, it is important to ensure that the metal studs are properly grounded. This can be accomplished by bonding the metal studs to the building's grounding system. The NEC provides specific requirements for the grounding of electrical systems. These requirements are designed to ensure that the electrical system is safe and reliable. It is important to consult the NEC and any other applicable codes and regulations to ensure that the grounding system is in compliance with all requirements. In addition to grounding, surge protection is another important consideration for electrical systems. Surges are transient overvoltage events that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protection devices, or SPDs, are designed to protect electronic equipment from surges. SPD are typically installed at the service entrance of a building or at individual electrical panels. When installing ENT, it is important to consider the need for surge protection. If the electrical system is susceptible to surges, it may be necessary to install SPD to protect the equipment connected to the system. The NEC provides specific requirements for the installation of SPD. These requirements are designed to ensure that the SPD are properly installed and that they will provide adequate protection from surges. It is important to consult the NEC and any other applicable codes and regulations to ensure that the surge protection system is in compliance with all requirements. Consider another situation. If the ENT is being installed in a corrosive environment such as a chemical plant or a wastewater treatment facility, it may be necessary to use special corrosion-resistant materials. ENT is typically made of PVC, which is resistant to many corrosive chemicals. However, some chemicals can attack PVC and cause it to degrade. In these types of environments, it may be necessary to use ENT made of more corrosion-resistant materials, such as fiberglass or stainless steel. The bushings used in corrosive environments should also be made of corrosion-resistant materials. Plastic bushings are typically suitable for most corrosive environments. However, in extremely corrosive environments, it may be necessary to use bushings made of stainless steel or other corrosion-resistant metals. It is important to consult with a qualified engineer or corrosion specialist to determine the appropriate materials for the specific application. Another important consideration when installing ENT is the ambient temperature. ENT is typically rated for use in ambient temperatures ranging from -20 degrees Celsius to +60 degrees Celsius. If the ENT is being installed in an environment where the ambient temperature exceeds these limits, it may be necessary to use special high-temperature or low-temperature ENT. High-temperature ENT is typically made of materials such as Teflon or silicone, which are able to withstand high temperatures without degrading. Low-temperature ENT is typically made of materials such as polyethylene or polypropylene, which are able to withstand low temperatures without becoming brittle. The bushings used in extreme temperature environments should also be made of materials that are suitable for the specific temperature range. It is important to consult with a qualified engineer or material specialist to determine the appropriate materials for the specific application. The size of the ENT also depends on the number and size of conductors that will be installed inside the conduit. The NEC provides tables that specify the maximum number of conductors that can be installed in different sizes of ENT. These tables take into account the size of the conductors, the type of insulation, and the fill percentage of the conduit. It is important to consult these tables to ensure that the ENT is properly sized for the conductors that will be installed inside it. If the ENT is undersized, it can be difficult to pull the conductors through the conduit, and it can also lead to overheating and other electrical problems. The installation of ENT should be performed by a qualified electrician. Electrical work can be dangerous, and it is important to have the proper training and experience to perform the work safely. A qualified electrician will be familiar with the NEC and other applicable codes and regulations, and they will be able to ensure that the installation is performed in a safe and compliant manner. The qualified electrician will also be able to identify any potential hazards and take steps to mitigate them. When hiring an electrician, it is important to check their credentials and make sure that they are properly licensed and insured. You should also ask for references and check them to make sure that the electrician has a good reputation. The selection of the correct type of bushing is very important. If you are using a metal stud with a pre-punch knockout, you need to ensure that the bushing is designed to fit that specific knockout size. Some manufacturers offer combination bushings that can be used with different knockout sizes. If you are drilling your own holes in the metal studs, you need to make sure that the holes are smooth and free of any burrs. You should also use a drill bit that is specifically designed for drilling metal studs. After drilling the holes, you should debur the edges of the holes to remove any sharp edges. It is also important to make sure that the ENT is properly supported. The NEC requires that ENT be supported at intervals not exceeding 3 feet. The support should be designed to securely hold the ENT in place and prevent it from sagging or moving. There are many different types of ENT supports available, so you should choose the type that is best suited for your specific application. In some cases, it may be necessary to use a combination of different types of supports. If the ENT is being installed in a suspended ceiling, you should use supports that are specifically designed for suspended ceilings. These supports typically consist of a wire or cable that is attached to the ceiling grid and then to the ENT. The support should be spaced at intervals not exceeding 3 feet, and they should be installed in accordance with the manufacturer's instructions. When installing ENT, it is important to be aware of the potential for condensation. Condensation can form inside the ENT if there is a temperature difference between the inside and outside of the conduit. This condensation can damage the conductors and other electrical components. To prevent condensation, you should seal the ends of the ENT with a suitable sealant. You should also use the desiccant inside the conduit to absorb any moisture that may accumulate. Another factor to consider is electromagnetic interference, often referred to as EMI. EMI can interfere with the operation of electronic equipment. To reduce EMI, you should use shielded ENT. Shielded ENT is made of a conductive material that is designed to block EMI. The shielding should be properly grounded to ensure that it is effective. Another aspect is the accessibility. The NEC requires that electrical wiring be accessible for inspection and maintenance. This means that the ENT should be installed in a location where it can be easily accessed. If the ENT is being installed behind a wall or ceiling, you should provide an access panel or other means of access. The access panel should be large enough to allow you to easily inspect and maintain the wiring. When installing ENT, you should always follow the manufacturer's instructions. The manufacturer's instructions will provide specific guidance on the proper installation of the ENT. The manufacturer's instructions may also provide information on the limitations of the ENT and any potential hazards that may be associated with its use. Before starting any electrical work, you should always review the manufacturer's instructions and make sure that you understand them. You should also make sure that you have all of the necessary tools and materials before you start the work. Remember to always inspect the ENT before installing it. Look for any signs of damage, such as cracks, dents, or punctures. If you find any damage, do not use the ENT. Replace it with a new piece of ENT. When cutting ENT, use a sharp knife or saw. Make sure that the cut is clean and smooth. Remove any burrs or sharp edges from the cut end of the ENT. When bending ENT, use a bender that is specifically designed for bending ENT. Do not try to bend ENT by hand. This can damage the ENT and make it difficult to install. When connecting ENT to a fitting, make sure that the fitting is properly sized for the ENT. The fitting should fit snugly on the ENT. Do not over-tighten the fitting. This can damage the ENT. When pulling conductors through ENT, use a lubricant that is specifically designed for pulling conductors. Do not use oil or grease. These can damage the insulation on the conductors. Pull the conductors slowly and carefully. Do not pull too hard. This can damage the conductors or the ENT. Once the conductors are installed, inspect them to make sure that they are not damaged. Look for any signs of cuts, abrasions, or punctures. If you find any damage, replace the conductor. Finally, always test the electrical system after you have completed the installation. This will ensure that the system is working properly and that it is safe to use. Use a voltmeter to check the voltage. Use an ammeter to check the current. Use an ohmmeter to check the resistance. If you find any problems, correct them before using the system.